I'm Tariq, CEO of Sonar. I'm so thankful that you've chosen to join us at Sonar Summit. We have an amazing lineup for you. Speakers from Sonar, thought leaders from around the world, and representatives from our customers and partners. We hope that you'll find it helpful, that you'll learn something new, and walk away with a few ideas. Many of you are longtime Sonar users. I want to say at the outset, on behalf of all Sonar sourcers, thank you. Sonar has been a developer-oriented company since our beginning as an open source project, and today there's over 7 million of you around the world who use Sonar to improve trust in software development. We wouldn't be here without you. For those who are new to Sonar or who haven't spoken to us in a while, let me tell you a little about us. As I mentioned, we started life as an open source project. Our core platform, Sonar Cube, has over 7 million developers using us on-prem, in the cloud, and in their IDE. We helped to pioneer the code verification space, and thanks to all of you, we're the industry's leading trust and verification platform for code. We work with you across over 40 different programming languages, from Python to COBOL, and employ a range of sophisticated mathematical reasoning algorithms to help detect over 7,000 different types of issues that could exist in your code. These algorithms help make your code better, more reliable, more readable, more maintainable, lower tech debt, less complex, and more secure. The analysis is fast. It is deterministic, so you get the same result every time. It is transparent, so you know exactly what was checked, what was found, and why. It is comprehensive, looking at your entire code base and understanding not just the literal code, but the architecture, the data flows, really whatever helps you verify and trust your code. We help you define quality profiles. What are the standards you, your regulators, your auditors, your executives need to meet? This could be because of best practice, personal preference, or compliance, whether you're looking to certify for MISRA, NIST, Secure Software Development Framework, SOC 2, or a range of other regulations. We help you enforce these profiles with quality gates, ensuring that the code that you or your AI checks in meets the standards you've set. We do this with the lowest false positive rates in the industry, less than 3%, and we do it with advice, guidance, and AI-powered suggestions about how you can address any issues that are found. You'll hear a lot more about our capabilities and roadmap over the course of the summit. We are very fortunate, and again thankful, that hundreds of thousands of instances exist inside of organizations, that over 25,000 companies choose to use our enterprise capabilities, including 75% of the Fortune 100, 19 of the top 20 banks in the world outside of China, leading technology companies like NVIDIA, top retailers and healthcare providers, public sector institutions from around the world. On behalf of our customers, Sonar analyzes over 750 billion lines of code every day, trillions of lines of code every quarter. It doesn't matter whether you wrote the code yourself or whether ChatGPT, Cursor, Claude, Codex, Devin, Copilot wrote the code. Leveraging our MCP server, APIs, and soon our CLI tools, we are integrated with virtually all major AI coding systems and with systems of record you rely on: JFrog, ServiceNow, Jira, GitHub, GitLab, you name it. And the goal of all of that is simple: reliable, maintainable, understandable, secure code built right at the start. One stat brings this to life. Sonar customers report that they are 44% less likely to experience an outage due to AI compared to people who do not use Sonar. 44% less. Verified code is safer, more secure, more reliable. AI models are great, but the old expression has never been more true. Trust, but verify. Or as we sometimes like to say, vibe then verify. And now, as proud as we are of everything I just said, we know we can't rest on our laurels. We've been doing a lot of thinking about the future of software development, and I want to spend the rest of my time sharing my thoughts with you. It's important, really critical, to say that nobody knows where this is heading, but I think we can make some educated guesses. So let's get started. And I'm going to start with a provocative statement. The era of continuous integration, with its familiar processes and workflows, is rapidly coming to an end. Traditional CI relies on developers making small, frequent, iterative commits. That continuous part is changing. Agents don't work like that. They operate in asynchronous batches, often working for long periods before dropping massive, complex payloads of code. We are seeing the emergence of a new paradigm that will fundamentally reshape how we create software. We're calling this agent-centric development. For good reason, there's a lot of discussion and adoption of code generation tools and agents. These have undeniable strengths that are transforming how developers do their job. But there's a growing consensus that developers will be focusing more on design, architecture, and planning, and then on monitoring, verification, and review. Less discussed are the changes required to ensure that the software development agents themselves are operating in a trustworthy, consistent, transparent, and responsible manner. Even in the best hands, AI slop is pervasive. Our research has demonstrated that left unchecked, coding models generate verbose, complex, buggy, and insecure code. Agentic development requires strong, deliberate, intentional set of practices and well-constructed set of tools. These provide guardrails, transparency, assurances, and verification necessary to build world-class software. We call this the Agent-Centric Development Lifecycle, or ACDC. Yes, it is electrifying. That is my first and hopefully last dad joke this talk. This model operates on a different set of steps than the legacy CI model. Because the continuous human cadence is gone, agents work for a longer period of time before they're actually ready to commit code. Code generation is fast, and the code is verbose. Pull requests are much larger and more complex. Small errors that the agent makes early in their process compound, making the process inherently unstable. It is much harder to understand the changes that are being made to the code base, presenting long-term risks and challenges. Security issues, for example, could creep in without being noticed when 40,000 lines are being checked in versus 2,000 or 300. But even with agents writing the code, developers are still responsible. Not just for the code, they're responsible for shipping something that works. Activities that used to happen post the build stage of CI/CD, such as dynamic testing, will now happen in the sandbox, will happen as the code is being written, and be the developer's responsibility. The speed and volume is overwhelming. Traditional manual code review approaches just don't work. This is not the normal shift left. It is more akin to being in the matrix. There is no right in the traditional pipeline. Before any code is checked in, there has to be the proof of a verified high-quality product. Because the continuous micro commit is dead, production grade validation must happen before the code is submitted in an agentic world. The paradigm fundamentally needs to change. We define the Agent-Centric Development Cycle, ACDC, as having 4 discrete stages. These stages are guide, generate, verify, and solve. ACDC happens both in the inner loop and the outer loop. That is, guide, generate, verify, and solve happens in each agentic reasoning loop, ensuring that the agent stays on track as it methodically works to achieve the plans. These are essentially micro adjustments that are continuously made using guardrails, prompt traces, rapid verification analyses. And then guide, generate, verify, and solve happens once the agent has finished its work. Here, the more comprehensive verification occurs, and often the agent will have to fix larger scale issues that are identified. So let's take a step back and examine the critical parts of the ACDC. Most companies we see have multiple coding agents in-house. Copilot, Claude Code, Lovable, Devon, Codex, all frequently coexist, used for different use cases or just based on developer preference. Everyone wants to trust these agents, but there are examples everywhere that show that you just can't. Blind trust is not an option. Every company will need a platform that feeds the generation tools, that guides them, that verifies them, and solves the complex problems that arise. So let's start with guide. Guiding is not just about pointing to a code base. It's about defining the playing field and setting the rules of engagement. Agents need to be told the context and the constraints that will shape their work. This is critical in both greenfield and brownfield environments to ensure that hallucinations do not occur. Agents need to know, of course, what the specifications are, but that's just the start. They need to understand the standards, the regulations, the guidelines, and the guardrails you've established for your code base, along with the current and desired architecture. After guide, then you have to verify. The code is generated, but AI makes mistakes, lots of them. Unlike developers, they don't make basic mistakes very often. Instead, they make very complex, hard-to-find mistakes. And the models themselves are both unpredictable due to their probabilistic nature and very sensitive to changes in their training set and environments. A prompt that worked well yesterday has no guarantee of working well today. Anthropic themselves published a terrific paper about 4 months ago showing how sensitive models are to data poisoning. Given these stark realities, verification must be thorough, transparent, and consistent. It has to happen in the inner loop as the agents look to continuously self-verify during the reasoning process itself. It then has to happen in the outer loop. Once the agent believes it has constructed a good solution, the developer must have the confidence that the work achieves the intended functional and non-functional outcomes, that it meets the internal standards, compliance requirements, that it's maintainable, that it does the job it was intended to do with consistency, with evidence, and with enterprise audit trails. Not just code review, but rigorous, transparent, deterministic, comprehensive verification. But no matter how much we verify, problems are inevitable. We have to expect that some things will slip through. The solve phase is the automatic debugging and remediation based on verification feedback. Armed with a deep understanding of the application structure and the results from the verification phase, corrections can be made. And unlike most traditional processes, failure is not just a bug to be patched. It's a lesson that refines the next iteration, making the entire system more resilient. Many of the traditional SDLC solutions will need to evolve quickly or be increasingly irrelevant as agents take over the development process. Critical components of the new ACDC cycle include, first, you need an agentic development environment. That is an environment in which the guide, generate, verify, solve loops can work for all your agents, regardless of what agent and code generation partner you use. Then you need to have a context engine. You need to have the tools that can provide useful context. For example, a thorough evaluation of your code-based architecture and crisp, transparent, and specific articulations of the guardrails and standards you're looking to achieve. You need to determine which pieces of context should be provided in each circumstance. Too much context, too little context, or incorrect context can all degrade the performance instead of enhancing it. And then last, but certainly not least, and perhaps most important, you need a trust and verification platform. Software development worked because, generally speaking, companies trusted that developers were going to write good code and review that code. Verification was important, but many treated it as optional given trust was so high. Agent-centric development breaks that compact. AI-assisted and agentic workflows create code at such high volumes and speed that pull requests are 10x or larger than in the past. Truly understanding the new code is almost impossible. The models themselves are black boxes, and the output is very sensitive to the input. Verification is mandatory in the ACDC, not optional. Like context, verification is an area that can become problematic quickly. Many of the easy approaches to verification, such as using LLMs to check their own work, can generate a high level of false positives and are neither explainable nor consistent. While they can be helpful, these inherently imprecise approaches have to be grounded in deterministic, comprehensive, and transparent analyses to maximize signal and meet enterprise standards. They have to make it clear to the developer who is accountable for the work precisely what was checked, what worked, and what did not work. There are many valuable sources of verification data. Deterministic code analysis, such as that produced by Sonar is a vital component. LLM-based AI code review is a helpful addition, but its non-deterministic and non-comprehensive nature means that it has to be a complement, not a replacement. Inside of whatever sandbox your agent's working in, the code can be tested and observability traces generated to produce additional information. A comprehensive verification platform aggregates and intermediates these signals and ultimately will pass judgment on the end result. Now, those are the required pieces of the ACDC. We think that there are also some emerging best practices that demonstrably improve overall agentic performance. For example, embedded context. Models are a reflection of their training data and techniques, and while the foundation model companies are continuously updating their training data, the vast majority of that training data is based on open source code. The quality, style, and standards used for these open source data sets are highly varied, and perhaps most importantly, they are different from what you and your company want and have used in the past. Fine-tuning models where the model provider allows helps to both improve absolute quality and security while also having the models better reflect the context embedded in your code base. As agent-centric development progresses, we believe there will be an increasing recognition of the need for these fine-tuned enterprise models. This is complementary to, not competitive with, the more transient, task-specific context from the context engine I mentioned earlier. We will see more and more special purpose agents. Today, the baseline foundation models generate a lot of excitement. However, addressing specific problems in software development likely requires smaller models and agents that are custom built for purpose. A code repair agent with custom workflows and understanding of the verification context, can better address the solve part of the ACDC. Code review agents trained on pull request information are likely to provide developers with better information than a generic review agent. This space is emerging and is worth watching and experimenting with. Now, we all know these changes cannot happen overnight. Enterprises have existing code, existing systems of record, existing workflows, existing tooling. It is not only impractical, it is ill-advised to rush headfirst into the ACDC. There are some practical steps you can take to get started. First, build your verification platform. As I mentioned, verification is mandatory, not optional. Our best customers who are adopting agents to write code at scale insist and require that 100% of the code written by AI is reviewed by SonarCube. Second, enable automatic tool calling. You need to make your verification tools and your context available in the way that the agents will consume them. MCP servers, hooks, programmatic tool calling. Make sure you're engaging at the speed of the agents. Most processes need to speed up, and the model providers and the agent providers are providing the capabilities to trigger the tools that you need. Third, employ agentic approaches to opportunistic hunting and solving your backlogs. Hunter agents can catch things that other techniques miss, amplifying your bug bounty programs. Remediation agents, on the other hand, can work through your backlogs, improving your baseline posture. With these simple steps, the speed of progress you can make on ACDC is truly shocking. Now, Sonar's roots are in the code quality verification space. Our focus has always been on having the highest true positive rate and the lowest false positive rate in the industry, while maintaining broad coverage of languages and issues across reliability, maintainability, and security. Of course, we are not sitting still. We are intensely focused on being the foundational platform for the Agent-Centric Development Cycle. Here's how our current and emerging initiatives map to the ACDC framework. For each of our customers, we have a deep level of insight into your code base, its structure, architecture, and data flows. Through our quality profiles, we also capture and understand what's important to your specific organization, whether you're enforcing standards set by your CIO or looking to achieve MISRA or Cyber Resilience Act compliance. One step is dynamic context. We have launched our public beta of our context augmentation service, which captures your guardrails, architectural intent, and other vital elements of context about your codebase to feed into your agents. We also have in private beta our embedded context offering, which we call Sonar Sweep. Sonar Sweep provides an industry-leading approach to embedding your existing code-based context into a custom model, a fine-tuned model, providing a correct at the source level of assurance. Fine-tuning your models on a swept version of your codebase can materially reduce the number of security issues and bugs that the models produce. Next, verify. Evolving far beyond our roots in traditional static code analysis, we use deterministic mathematical reasoning methods to provide transparent, consistent, and repeatable results that meet corporate and regulatory needs. In our core, we're actively employing AI to enhance the value we can provide to you. We use a variety of AI-enhanced techniques to improve the breadth and quality of our reasoning algorithms. We employ embedded AI to find and further reduce false positives beyond our current industry-leading levels. And coming soon, we're using AI to help triage and prioritize issues specifically for you, given your unique context and code base. Our users have historically been the millions of developers who have SonarCube embedded in their workflows. Moving forward, we will also be used by the agents who are writing code for you. So we're upgrading our analyzers to optimize them for agentic analysis. This is big and will allow SonarCube to be used in self-verification of agents. But we are not stopping with our core. We believe that the best verification platforms will leverage deterministic systems combined thoughtfully with a range of other verification techniques, including LLM-based capabilities. For example, we have hunting agents in early access designed to use LLM-based reasoning techniques to opportunistically spot-check code bases for security issues and bugs. Our early tests have caught over 200 CVEs in open source projects. Now, let's move on to solve. SonarCube has long been focused on ensuring that our findings are actionable and identified issues are resolved as quickly as possible. Past efforts focusing on adopting a clean-as-you-code methodology and learn-as-you-code content were developer-focused initiatives to improve code-base quality and health. These philosophies are still incredibly valuable in an AI-centric world, and we're enhancing them specifically for the AC/DC. AI CodeFix is available as a default capability inside of SonarQube Enterprise plans, allowing you to bring your favorite LLMs to suggest fixes to issues identified by SonarQube. And SonarQube Remediation Agent, now in public beta, builds on our benchmark-leading Sonar Foundation agent to automatically remediate a large number of issues identified during the verification steps. All of this is seamlessly enabled for tool use within Claude Code, Google Anti-Gravity, Cursor, and other AI coding tools using SonarQube MCP server, as well as the now available SonarQube CLI. Put together, Sonar provides the comprehensive end-to-end guide, verify, solve capabilities required to safely and reliably power any of your chosen code generation tools and agents. So that's a view of the future and our roadmap. We have high ambitions because we know that you have high ambitions. We're moving quickly because we know that you are moving quickly. Throughout the Sonar Summit, our teams will go into a lot more detail. There's over 50 sessions for you to enjoy. Throughout those sessions, we'll all learn and we'll evolve together as the world continues to change. But really, I want to close the way I started, with a thank you. It's a real privilege and a real honor to be able to work with all of you. So thank you, and I hope you'll enjoy the rest of the summit.